Okay, so we'll do another example now of a number that's in the second quadrant. So this number is minus 3 plus root 3i. So minus 3 on the real axis and up 3i on the imaginary axis. So just draw that in here. And there's my complex number. Okay, so now the angle I actually require here for the argument is this. Okay, that'll be my argument. Okay. But I'll actually find this one first, okay, using alpha. And we'll use the exact same technique as we used when we're doing trigonometry, trying to get the reference angle into the quadrant that you require. Okay, and the length of the complex number is obviously, again, just its distance out from 0. Okay, so we'll use r equals the square root of minus 3 squared plus root 3 squared. Now remember here, don't put in the I. The I is only there to tell you that it's on the imaginary axis. Here we're trying to find the length of this, so we're simply dealing with the number parts. Okay, so don't ever put I in here, or you will get I squared, which will give you minus 1 and which will alter your results. So putting all that into the calculator, we get 2 root 3. So that's our R found. Now our argument, well, we proceed as normal with our inverse tan. Because if you still look at this, we still have a triangle over here, even if I complete it. I have this side here, and I have this side here. So I know that the bottom of it is minus 3, and this side of it here is root 3. So again, this corresponds to inverse tan of imaginary over real. Now, you either leave out the signs or else you take the absolute value, whichever way, it doesn't matter. Okay, but you need to be taking the positive value. Now, so that's pi over 6. So basically, that's telling us then that alpha is pi over 6. Okay, so our alpha there is pi over 6. So now we need to get theta. Well, we can see that's the same as in trigonometry. We go right around to that whole line, which would be 180 degrees. So that tells us then that theta would be 180 degrees, or we're working in radians here, so pi. And I'm going to take out the red part. So pi minus pi over 6. So that means we'd have 6 pi over 6 minus pi over 6, which will give me 5 pi over 6. Okay, so this will tell me then that my complex number is, remember, it's r cos theta, I sine theta. So then my number will be, what did I have? 2 root 3 times the cos of 5 pi over 6 plus I sine 5 pi over 6. Okay, so let's see what our calculator yields for this. So again, we go shift pol for polar, put in our minus 3, comma, root 3, close my bracket and press equals. Okay, so now as you can see, we have both our answers here, and neither of them look too pleasant. Now remember what I said? That we store, when the calculator has two answers, it stores the first answer in x and it stores the second answer in y. So if I recall x, I get 2 root 3, which is what I have for my r. And now I'll recall y, and I get my 5 pi over 6. So they can be really helpful in telling you, getting exactly the angles that you actually require and the r, and at least then you can force your answer to work.